Alright, in our last video we learned about some equivalent trig functions. Sine of a plus b, cos of a plus b, sine of a minus b, cos a minus b, sine of 2a, and cos of 2a. Here we have sine 2 theta, cos 2 theta. The variable really doesn't matter. And this is just, so like we know our basics, like I know the sine of pi by 4 is equal to 1 over root 2, or you can say root 2 over 2 if you prefer. But, you know, who knows what the sine of pi by, 5 pi by 12 would be. And if you go back to our other video, we show you how to solve that using these formulas. All right, but there are more than these 6 formulas, and you're going to want to, have use of more than these. So let's go over some more common formulas that you're going to need, such as, let's try tan of 2 theta. Okay, let's go back one. All right, so we know that, on our unit circle, if we have a unit circle here, we know when you have a point on that unit circle, this angle right here, let's call that theta. We know that the height here is the sine of theta, and the distance this way is the cosine of theta, and the slope of this curve is the tan. Slope equals a tan of theta, but also sine theta over the cosine of theta equals a tan of theta. That's delta y over delta x. So if you know the sine of an angle and you know the cosine of an angle, then you could easily figure out the exact value of the tan of that angle. Okay, and we do know like sine of pi by 2 and cos of pi by 2 and things like that. So similarly to why we would use sine of 2 theta and cos of 2 theta, we're also going to want to know tan of 2 theta sometimes, in case we want to know the tan of 5 pi by 12 or anything like that. So what does that equal? Well, the tan of 2 theta is simply sine of that angle divided by the cosine of that angle. Okay, well, since the sine of 2 theta is just 2 sine theta cosine theta, and the cosine of 2 theta is just cos squared theta minus sine squared theta. Now we want this in terms of tan of theta, so let's use a little trick. Let's divide the top and the bottom by cos squared theta. So you're going to have 2 sine theta cos theta divided by cos squared theta. As long as we do the same thing to the top and the bottom, then we shouldn't have a problem. And so we get cos squared theta minus sine squared theta all over cos squared theta. And that's going to be equal to, so it's going to be 2. Now sine over cos is tan of theta. So we're going to take one of these cosines and put it with the sine. And the other one just cancels out. Cosine over cosine is equal to 1. On the other side, we have cos squared theta over cos squared theta, which is 1, minus sine squared theta over cos squared theta, which is just sine theta over cos theta times sine theta over cos theta, which is tan squared theta. Okay, so we know that tan of 2 theta, of 2 theta is equal to 2 tan theta over 1 minus tan squared theta. Okay, so for example, if I wanted to know the tan of, well, if I knew the tan of any one angle, and I wanted to find the tan of double that angle, well, I could just multiply the tan of the first one by 2, and do 1 minus the first one squared, and you will get the second one. Okay, so that's another identity that's important to know. And I'm going to go through some more for you guys. We're going to use the unit circle again. We're just going to go over things we already know about it. Okay, so if I have an angle, it doesn't matter what quadrant we're in, first, second, third, fourth. It really doesn't matter where you are. The angle here, let's call this angle theta. Okay, we'll determine your sine of theta, which is this height, and your cosine of theta, which is this distance to the right. Over here, the cosine of theta will be negative. Over here, both sine and cosine will be negative. That's neither here nor there, because what we're going to say is that radius is always 1, no matter what. That's the whole point of the unit circle. Okay, so then we can actually say that this side, which is sine of theta, sine squared of theta, if you square it, and this is cos of theta, so plus cos squared of theta is going to equal 1 squared, the Pythagorean theorem. This squared plus this squared equals this squared. And it doesn't matter what angle. Like here, you're going to have negative, so the cos theta is going to be a negative number. When you square it, it's still going to be positive. This is going to be a positive number. When you square it, it'll be positive. No matter what, they'll be both be positive. And when you add them together, right, you're going to get 1. Okay, so sine squared of theta plus cos squared of theta will always equal 1. Right, let's try out a few that we already know. So we know the sine of pi by 4 equals 1 over root 2, or root 2 over 2 if you prefer. Doesn't matter. And the cosine of pi by 4 is the same thing. Equals 1 over root 2. And so let's try sine squared theta, cos squared theta when theta is pi by 4. So you're going to get sine squared theta is going to be 1 over root 2 squared plus cos squared theta is going to be 1 over root 2 squared. And let's just see if that equals 1. Well, 1 over root 2 squared is 1 over root 2 times root 2 is 2. Plus 1 times 1 is 1. Root 2 times root 2 is 2. 1/2 plus 1/2, sure enough, equals 1. All right, maybe we can try it for, let's say, pi by 3. So we know the sine of pi by 3 is root 3 over 2. That's memorized. The cosine of pi by 3 is 1/2. Right, so when we have this angle up here, we got root 3 over 2 is the height, and 1/2 is the distance to the right. Well, let's see. Sine squared theta, so root 3 over 2 squared, plus cos squared theta, 1/2 squared, is equal to, let's see if it equals 1. Root 3 squared is 3, 2 squared is 4, 1 squared is 1, 2 squared is 4, 3/4 plus 1/4, sure enough, equals 1. And it'll work for any angle. You name the angle, it'll always work. To solve equations or to prove equivalent equations is sine squared theta plus cos squared theta equals 1. And it doesn't matter what the angle is. So we're actually going to use this identity, sine squared theta plus cos squared theta equals 1, to help us expand. And there, cos 2 theta can actually be written in 2 different ways. So you have cos 2 theta is equals cos squared theta minus sine squared theta. And if we could replace sine squared theta, since we know that sine squared theta plus cos squared theta equals 1, we can replace sine squared theta with 1 minus cos squared theta. Right? Because if they add up to 1, then if you take cos squared theta away from 1, you're going to get sine squared. So we have cos of 2 theta equals cos squared theta minus 1 minus cos squared theta. And so cos of 2 theta is just equal to 2 cos squared theta minus 1. So you have your cos squared theta minus a negative cos squared theta. So it's plus another cos squared theta here. So 2 cos squared theta minus 1. Now, you could also write cos of 2 theta is equal to, now we're going to replace cos squared theta this time with 1 minus sine squared theta. Again, if they both add up to 1, if cos squared plus sine squared add up to 1, then if you take either one of them away from 1, you'll get the other. So cos of 2 theta is equal to 1 minus sine squared theta, which is just your cos squared theta there, minus another sine squared theta. So that's cos 2 theta simply equals 1 minus 2 sine squared thetas. So we actually have 3 different ways to write cosine of 2 theta, and it kind of depends on whichever one's the most convenient at the time. That's the one that you would use. I'd just like to draw your attention to the cos 2 theta and cos squared theta, and just make sure you know that those are 2 completely different things, right? So let's say theta is equal to, let's say 3 pi by 7. Right, now 2 theta is just going to be 6 pi by 7, right? 2 times 3 pi by 7. Whereas, so cos of 2 theta is just going to be cos of 6 pi by 7. Whereas cos squared theta, totally different, is going to equal cos of 3 pi by 7 times cos of 3 pi by 7. Okay, so it's cos squared theta is cos theta times cos theta. So just be really careful. There's a huge difference between squared and times 2. Now, you probably notice here you have sine 2 theta, cos 2 theta, tan 2 theta, and we actually have 3 forms of cos 2 theta conveniently. But up here, sine of a plus b, cos of a plus b, sine of a minus b, cos of a minus b, we don't have tan of a plus b or cosine or tan of a minus b. All right, so let's just derive that. We got tan of a plus b. Well, we know that that's going to be equal to sine of a plus b divided by the cosine of a plus b, because tan of anything is just sine over the cos of that same angle. So we're going to use our equations up here to find out what tan of a plus b is. So we've got sine a cos b plus cos a sine b, which is sine of a plus b. It's just easier to take the a plus b and break it into cos a and sine b, because we know the single angles sometimes and we don't know the double angles by heart, so it just makes it easier. So we're going to put that over the cos of a plus b, which is cos a cos b minus sine a sine b, to make tan of a plus b. All right, we just use the equations from up there. Now we actually want this in terms of tan A and tan B, so we're going to use a little trick. We're going to divide both sides by cos A cos B. So you're going to have sine A cos of B plus cos A sine B. We're going to divide that all by cosine A times the cosine of B. And that's all going to be over the bottom, the denominator, which is cos A cos B minus sine A sine B. And we're also going to divide that by cos A cos B. So if we divide the top and the bottom by the same thing, we're going to keep the equality. Right? So it's just, there's the top, there's the bottom. We're going to divide them both by cos A cos B. So in the numerator, sine A cos B divided by cos A cos B, the cos B will just cancel out, and you're going to be left with sine A over cos A. And the second part, you're going to have cos A sine B divided by cos A cos B. Well, cos A will cancel with cos A, and you're left with sine B over cosine of B. And that's all over, so that's for the numerator. Now in the denominator, cos A cos B divided by cos A cos B, well, that just equals 1, minus sine A sine B divided by cos A cos B. There you go. All right, that's just going to be tan A tan B, by the way. So this is equal to sine A over cos A is just tan of A, plus sine B over cos B, which is just tan of B. All that over 1 minus, well, sine A over cos A is tan A. Sine B over cos B is tan of B. Right? You have tan A over cos, sine A over cos A times sine B over cos B, and that's just tan A times tan B. And that is equal to tan of A plus B. So we could actually add that to our set of equations at the top. Now the same sort of thing can be done for tan of A minus B. We could either just use sine of A minus B over cosine of A minus B, tan of A minus B, or we can actually use tan of A plus B now that we know it, and just replace B with a negative B, right? So we can just say tan of an angle A plus angle negative B. Either way, you're going to end up with tan of A minus B is equal to tan A minus tan B over 1 plus tan A tan B. Alright, I'll write in the process here, but I'm not going to bore you guys with it. I'll just throw it in, and if you feel like pausing, you can take a look. Alright, so we have our addition and subtraction formulas here for sine, cos, and tan. We have our double angle formulas for sine, cos, and tan with 2 bonus for cosine here. We also have a Pythagorean identity right here, saying sine squared plus cos squared equals 1. Now we can also use that Pythagorean identity and add a couple more in case we ever encounter something like secant squared or cosecant squared in our work. So all you have to do is just take your sine squared theta plus cos squared theta. We know those two added up equal 1. Well, what happens if I divide both sides by sine squared theta? Sine squared theta. Well, they'll still be equal, but sine squared theta over sine squared theta is just 1. Plus cos squared theta divided by sine squared theta. Well, that is just cos theta over sine theta is just cotangent of theta. And this would be cotangent squared of theta, right? Which is cos theta over sine theta times cos theta over sine theta. That just equals cotangent theta times cotangent theta. Remembering that cotangent is just the reciprocal of tangent. So if tangent is sine over cos, then cotangent is cos over sine. Okay? And that equals 1 over sine squared theta. So we can say 1 over sine theta times 1 over sine theta, which is sine squared. Well, 1 over sine theta is cosecant theta, and 1 over sine theta again is cosecant theta, so this is just cosecant squared of theta. So if you ever have cosecant squared theta, you could always replace it with 1 plus cotangent squared theta. Right? Those are equivalent as well. So we could add to our bag of tricks. 1 plus cotangent squared x is equal to cosecant squared x. All right, we could do the same thing again, except this time we're going to divide both sides by cos squared x. Here, cos squared theta. All right, so sine squared over cos squared is going to be tan squared of theta, plus cos squared over cos squared is just 1, and 1 over cos squared is just equal to secant squared of theta. So these three are considered your Pythagorean identities. Sine squared theta plus cos squared theta equals 1, and you've got your 1 plus cotangent squared theta equals cosecant squared theta, and you also have your tan squared theta plus 1 equals secant squared theta. All right, we should add the few simple identities that we knew from before. That's just tan of x is just equal to sine x over cosine x. This will obviously come in very handy. And cotangent of x is just the opposite. I should say the reciprocal is cos x over sine x, or 1 over tan x if you want. We also have cosecant x, these are just the reciprocal identities, is 1 over sine x. We have secant of x, which is 1 over cosine of x. And we have cotangent x, which is equal to 1 over tan of x. Alright guys, so these are a bunch of identities. It is expected that you understand them all, that you can work with all of these. We will be giving you sheets with all of these on it, so you never have to really memorize any of them. Of course, with time, I mean, your memory is you're just gonna start memorizing them all anyway. But these are gonna prove to be useful in order to, solve equations. If you have something that seems complicated, you could always change it to another form, and back and forth between forms to help you solve equations, and also to prove identities. An identity means that the two sides of the equation are the exact same thing for any value of x or for any value of theta, and so you're going to use these things quite a lot in the next little while.